Welcome, everyone. I'm a data science engineer at Placewise, and I'm also a PhD candidate at AGH. And surprisingly, I work with pipeline orchestrators, both in my work and also at AGH, because pipeline orchestration is used both in industry and in science. And I wanted to talk to you about mistakes. How can you shoot yourself in the foot when using pipeline orchestrators? What mistakes can you make and how to avoid them, more importantly? So I want to tell you in this presentation a cautionary tale. What not to do, what to consider, what to think about when you choose and use your pipeline orchestration tool. And I assure you, if you don't currently use it, you will, at least when you get into some problems. So let's talk about pipelines, because as we all know, in MLOps we build pipelines, either more manually or more automated. So first, I think you have all done that. We pull, firstly, data from some databases. So we make some queries in parallel, we wait a bit, we gather the results. For example, we dump the query results on S3. So we can make those queries in parallel. The VMs making the actual queries can be very, very small because they wait. The heavy lifting is in the database. And then, when all our queries finish and we have all our data, we can do the data processing. You know, the merging, cleaning, processing, use Apache Spark or, you know, the latest, hottest framework for data processing. But we need to all our queries to finish, so we have this sequential processing. We have this sequential waiting here, and this is RAM and CPU heavy. We need some computational clusters to do the data processing very often. And then when we have cleaned our data, then we can, of course, train our machine learning models. This requires GPUs, PyTorch, specialized frameworks, maybe use, for example, Vertex AI or SageMaker for this step. So we have some parallel processing. We have some sequential dependencies. We also have different VM requirements. So clearly, we do have a need for pipeline orchestration. Because we have this parallelism, we have task order, we have to manage different VM sizes. We also have external clusters, services. We need to manage passwords for those things. We need to pull those secrets in runtime. We also need to build a pipeline as its own thing, because pipeline in itself is a thing that we should manage in MLOps. We have to aggregate logs, errors, traces, execution times. We need not only to see our jobs as separate things, but as a part of a full pipeline. So we clearly need some tools to help us with those. And fortunately or unfortunately, we have a lot of those. We have some classics like Airflow or Argo. We have some newer players like Dagster and Prefect, which very much try to overcome Airflow as the most popular framework. We have some very new players like Flight, Orchestra. We also have cloud-specific like AWS Step Functions. So we have a lot of orchestrators with different strengths and weaknesses, and you can make a lot of mistakes with each and every one of them. And I want to talk to you about a few of those mistakes. But firstly, you may also have heard about Kedro, about Metaflow, about ZenML. Those are very popular frameworks, but I want to call them the syntax sugar over the orchestrators. Because those things are not orchestrators in themselves. They do not do the orchestration work. They make your work easier. For example, using Metaflow is much, much more nice than, for example, using AWS Step Functions by themselves. But they do need some orchestrator underneath to be set up in order to work. So you may use those things, but you still need one of those to actually do the orchestration work. So this small clarification first. And then I have a few traps that you can fall into when using orchestrators. By the way, all those quotes are the actual things that I have heard from my colleagues, from people from other companies. I have read on the internet. I have argued on Reddit. So yeah, those are all real things, real mistakes that someone has made. And this is the most common one. So the thing that many novices make is that they think that orchestrator and executor are basically the same thing. And this is a very grave mistake. It will cost you a lot of money. So orchestration engine does the orchestration. So it does not do the heavy lifting. Orchestration engine is not for data processing. Data orchestrator is for orchestrating the process, making sure that things go in parallel, that things go in sequence, that logs are gathered, errors are gathered, and they typically use orchestrator workers, which are very lightweight processes, because it only orchestrates other things. So those can be lightweight Python processes, Go routines, but they are very lightweight. But the actual processing you should do in, well, dedicated software. For example, in Kubernetes pods, cloud VMs, on Spark clusters, Ray clusters, on SageMaker, using PyTorch, whatever. But those are two very separate things. When you use orchestration engine, you also do need one or more execution engines which are separate. So yeah, if you typically use execution engines because you can't do anything without an execution engine, but you need an orchestration engine as a separate thing to orchestrate the process of your data processing, model training, etc. So why the distinction? Firstly, because tasks have different computational requirements. As we have said, if you make small queries to the VMs and just wait for results, you can use very lightweight VMs, which are very cheap. And orchestrator workers typically have uniform size. For example, in Airflow, you have one Python server process size. So if you wanted to use orchestration workers for data processing, you actually would need to scale your workers up to the largest task. And for example, use 15 gigabytes of RAM for each and every small orchestration task. This is clearly a bad idea. So you should not do this. Also, tasks have different library dependencies. If you install a lot of additional libraries on your orchestration workers, you can very easily have dependency hell, because especially in data science, we have a lot of dependencies, right, down to the compiled C, a lot of Python libraries. So you should separate your dependencies in different tasks. Do not put too many things on your orchestrator. And also, tasks use external resources. So those orchestration workers typically just wait. For example, if you use orchestration engine to orchestrate Spark jobs, Spark can, for example, do computations for multiple hours, and your orchestration actually does like 2 minutes of work for 24 hours of actual computation. So you should use small orchestrators. Do not put work on your orchestration workers. Because this is very efficient, if you only use it for small tasks, you can do small things, like, I don't know, make a single request to check a thing on your orchestrator worker, but you should not do the heavy lifting. You should put work on external services, like Kubernetes pods, and they are very easy to use, or cloud VMs. You can use database queries. Databases are great for data processing, or Spark, SageMaker, whatever. A lot of tools. You can use also serverless functions, which are great. They can scale very well. So serverless functions are great if you have some lightweight, very scalable or variable work. And you should also use external storage, because orchestrators are not for computation and they are not for holding data. For example, if you pass a lot of data between Airflow tasks, by default, they all get serialized to Postgres blob object and then get deserialized. So it takes a lot of work. So instead, you should use some object storage like S3 or GCS, or use databases dedicated for your data type. And you should not store data on workers themselves. So the trap number 2 is that we can easily self-host it. So let's see how easily can we self-host, for example, a typical Airflow. So this is the architecture diagram. This doesn't look that much complicated, right? We have some web server. We do know how to host web servers. We have a scheduler, okay, some workers, some external storage, some database, some logging setup, some logs gathering, some monitoring metrics. Oh, and also some user interface that we have to connect, or also some config. Okay, so setting this up manually is like a week of work. If you know what you are doing on your Kubernetes cluster. So clearly a bad idea. So, okay, maybe newer frameworks, because Airflow is quite dated, maybe newer frameworks are better. So let's see Flight. Flight is Kubernetes native. We have some Flight admin. We have some Kubernetes server. We need to set up etcd. We need some controllers, executors, node executors, Flight propeller to install. We also need some plugins and to synchronize all of this. So self-hosting an orchestrator can be a lot of work. And you do need an experienced DevOps to actually do this. But not all is lost. But firstly, we at the very least, from those diagrams, need three things to host an orchestrator ourselves. We need some scheduler, we need some workers, we need database for state tracking, because orchestrator at its heart is a distributed orchestration engine. It's a distributed system which has to synchronize the state between cloud-based distributed system. So it's very complicated by itself. The task is very hard that orchestrators do. We also need some web server to inspect our workflows visually. But we also should have logging setup, monitoring setup, also gathering all of this. Maybe set up OpenTelemetry to gather all our traces. We need to set up executors, connectors, secrets. We need to install maybe additional plugins because those orchestrators have modular structure. We need local development setup. We need some cluster setup for deployment. So this is a lot of work to do this properly, to scale, to be safe. So we have basically three options. How can we do this? We can self-host it totally. Like install each and every service, scale it ourselves, maybe use some Docker Compose. So this gives you a lot of control. The infra cost is very, very small because you can very, very tightly control it. But the developer cost and total cost of ownership is very, very high because you do need people to actually do this. And if you see how much an average senior DevOps makes an hour, well, this can be quite pricey, finally. But you can very easily develop this locally, so this has its advantages. You can also use Kubernetes if you have set up Kubernetes. Then you can use Helm charts. Helm charts are great. You just install my Helm chart and basically you're good to go. Of course, locally, your CPU will cry if it needs to run all of those services, for example, with Minikube, but this is doable. The developer cost is average. It can be very little if you have Kubernetes already set up and you just need to install it. But the infra cost can be also very little because Kubernetes scales those orchestrators very, very well in practice. But you also have managed services, cloud services. And they are actually very, very good if you are a reasonable scale company and need a single orchestration engine, for example, for multiple teams. Because this is very, very easy to set up. The costs can be higher in terms of infrastructure, but the DevOps cost is, well, basically non-existent, right? You need like half an hour to set up a cloud-based orchestrator. And you can also develop locally, but you need some separate setup. So you have to consider carefully the developer cost versus the infra cost in your solution. Check out, for example, costs of orchestrators, for example, on AWS, on Astronomer, on GCP, because they can differ a lot, also between orchestrators. And you should consider all those costs together, also the local development when you choose your orchestrator. Okay, so the trap number 3 is actually maybe not a trap, but a very important consideration how you should set up your Git structure when using orchestrators. Because we have very separate concerns from programmers and from orchestration infrastructure DevOps perspective. Because business and programmers care about doing the work, right? We want to train our machine learning models. We want to use some tools. We need to choose some data sources, connect to them. So we have more higher level, more business-oriented questions to ask. Whereas the orchestrator is concerned, for example, with the Helm chart version or Kubernetes version, or how to set up the scheduler, database, how to synchronize this, how to set up access, connectors, plugins. So the orchestrator is much lower level compared to the rest of our MLOps, really. So I personally do not like to use one Git repo for multiple orchestration projects because the orchestrator is an infrastructure in itself. It's a service. Large companies often have like a separate infra team, for example, that only manages the orchestration. Because the orchestration, if you have a larger company, is a service in itself for other teams that other teams can use. Because the orchestrator needs a repository, it needs CI/CD to update Helm charts, to update Kubernetes, for example, updating the orchestrator is a very hard task if you do not want to break the already running tasks. So this is actually a hard work in itself. So personally, I think the orchestrator should be managed as a separate product if you have a large enough company for internal usage. And you should also separate your workflows, because different workflows have a very, very different environments. For example, in one place that I worked in, we had basic Airflow setup, and one person said, okay, one repo will be enough, surely only the reporting, the BI team will use it. Okay, and then later came machine learning projects, and when they wanted to use it. Then came DevOps, and they wanted to use it, and we had a huge mess, because you should separate this into multiple Git repositories, because you will sooner or later have very, very different workflows. So using many different Git repos encourages this dependency separation. You will have different programming languages, different environments, ETL versus ML versus DevOps, yeah, very different workflows. They will use maybe even different orchestrators. And you should also check the support for this, because different orchestrators have different workflows in terms of Git management. And not many orchestrators support multiple Git repositories. In fact, Apache Airflow is the only one that has like a very standard setup port, or maybe some Kubernetes-based ones. This is where, by the way, this is where cloud-based orchestrators like AWS Step Functions have a huge advantage, because they are natively for multiple users. Typical options to deploy your workflows in terms of Git are, for example, you can use a single Docker image. You basically put all your code for all your workflows into a single Docker image and deploy this. This can scale surprisingly well. For example, there's a presentation on YouTube by Jagex. If you are old like me and played RuneScape, you may recall this company. So Jagex uses Apache Airflow, and they use single Docker image for deploying their DAGs, because it has some advantages in terms of versioning and being a static code. You can also use cloud storage with some pipelines. For example, Shopify uses this. They use Airflow with NFS to automatically synchronize their pipeline code using NFS, where they basically put all the new code using CI/CD. And you can also use Git sync sidecars if you use Kubernetes. This doesn't scale that well to very many repositories, but can scale reasonably well. So you should consider the options. You should maybe ask the developers. A lot of new orchestrators are putting a lot of work into communication. They have Slack, they have Discord, they have very active mailing lists. So you should ask maybe developers what they recommend in terms of deployment, in terms of managing Git, because this will be very important in the future when you scale. Okay, the trap number 4. Let's just use one VNF. Okay, this will surely scale. We'll have just a small set of dependencies. Yeah, this can be further from the truth. You absolutely should use different environments. For different, at least for different workflows, for different pipelines, you should have separate environments. But perfectly, you should have a separate environment for different tasks, because your tasks will be vastly different. For example, if you use a very weird API, but it has its own SDK, so only this task where you pull the data from this API should use this dependency. If you use your executors well, you separate them. For example, use SageMaker in one place, or Spark in another, or Simple Python in another. This comes very naturally to separate your dependencies. So this is actually not that hard, but you should keep this in mind. You can use Docker, of course. You can use external clusters. When you use Spark, for example, this comes really naturally to separate your dependencies between Spark jobs. You can also auto-install in Python in some frameworks. You just you make requirements.txt, and you put this on your to your orchestrator, and it automatically installs those dependencies in runtime when it starts the tasks. So it's quite convenient in some frameworks. But you absolutely should separate your dependencies in some way. Okay, so the trap number 5. This surely won't fail. Right? We have some tasks that we are sure they won't fail. They're on our internal Kubernetes cluster that is highly available, that is so great, it's cloud-based, so durable, this won't fail. Okay, so everything will fail. sooner or later. Even if you use like highly available, highly durable services, at some point you will get message from AWS that you have hardware corruption and you have to migrate some of your services. So we have transient hardware failures. We have software failures. We have bugs. Oh, we always have bugs. We can have worker failures for any reason. And also we can have orchestrator bugs. Orchestrators are software. Orchestrators can have bugs in themselves. So you should also always be prepared for failure. Your task will fail, but fortunately you can often prepare for it. And firstly, you should use retries. Basically, any orchestration framework enables retries, where you just can retry the task a few times. This is extremely useful, especially in the data gathering step, where you use external APIs, you have some service unavailable, errors. So absolutely you should use it. Either in your own code, for example, with Tenacity library in Python, or on orchestrator level. And you should also make your tasks idempotent. And this basically means that you can safely run the same thing twice with the same input. So you can safely rerun your task. For example, use upserts instead of inserts. I know this can get ugly in SQL. Not all databases support very nice upserts, but you absolutely should use this, because otherwise you will fail on insert, for example, primary key, unique will error if you try to insert new things. So you absolutely should use upserts. You should overwrite instead of failure on existence. So those are very basic things that ensure your tasks are idempotent. You can safely rerun your pipelines. And if you use retries, by the way, making the tasks idempotent is a requirement. Otherwise, you will get duplicates in your data. And you also will need sooner or later to backfill your historical data. For example, imagine we have holidays coming. Okay, so you start your orchestrating job that runs daily, you go on holidays, you come back, and there is no data for the last 2 weeks. Your latest release broke the pipeline. So what happens? You should be able to backfill your historical data. So run your pipeline for historical dates and regather this data. Sometimes retries won't work, pipelines won't run, so there are a lot of reasons for this. So plan for backfilling this. So we in the past I have written, and my colleagues have written, data fixing scripts, like manually fix the data for the last 2 weeks. This doesn't scale at all. So you should have some data recreation strategy. For example, use those upserts. For example, on every pipeline run, you may gather the data for the last 3 months and upsert it, instead of running the data just for the last week. This can get a bit costly, at least a bit more costly, but this will save you a lot of pain when the pipeline will fail. Sometimes this is not doable because some APIs only offer current data. So those APIs are a pain to work with, to gather data from, because if you want machine learning, you want all the data, you do not want any breaks in the past data, but having some resilient architecture can help with this. So for example, if the API is not available, okay, you can do nothing, right? You can't pull the data from it. But for example, if you use data lake architecture, this can actually help a lot in with gathering external events, because for example, you first dump raw events from the API on some storage, and only then, in the next step, you process them with the rest of your pipeline. So you make sure you at least have raw events to work with. So this can be very useful if you have unreliable APIs. Okay, so I think the last drop. Let's use this new hot framework, because we have a lot of orchestrators, a lot of new orchestrators. They offer you a lot. They have nice GitHubs, nice logos. They have like 1,000 stars on GitHub, so they look good. But actually, all of those new hot frameworks, early they have a lot of bugs because, well, writing an orchestrator is hard. This is a distributed system. It's very hard to get right. So actually having an older but more mature framework is a huge advantage here. And you should also look out for a few things in those orchestrators, what they support. For example, popularity is a feature, yeah, definitely. Less bugs, more features, more deployment options, more discussions on GitHub discussions, on Stack Overflow. You can also ask some people on Reddit and you'll probably get the answer. So popularity is a huge feature for orchestrators. And you also have more potential employees. Yeah, this is also a plus. Pipeline versioning. So some frameworks, especially older ones, most popularly Airflow, do not manage previous code versions. So for example, if you update your pipelines, they basically throw away the old code. For example, if they throw away old logs, if you change your tasks names. If you have any auditing needs, this is very, very important to choose an orchestrator that supports pipeline versioning, because without pipeline versioning, you will absolutely use some logs, some historical data about your orchestrator at some point in the future. Also data tracking, data lineage. If you have a lot of data processing, for example, what I do at the University of NLP, we have a lot of data tracking, very, very complicated processing. And then orchestrators that do support tracking this visually, what tasks input and output what data and what is it, is very important. This is especially important if you have complex flows in ETL or machine learning at big scale. If you use some, for example, feature stores for batch processing, online processing, this is very important then. Also for debugging, for optimization, this is very useful if you know where your data comes from, where it goes. Also built-in features. Airflow is often chosen by many companies because it has a lot of plugins. It does a lot of work for you. Newer frameworks sometimes have a few basic integrations, but not many. So also logging, monitoring integrations are extremely important because you want your logs, you want your monitoring. So you should absolutely consider what you need. If you have everything in-house, everything custom, then no problem, you can use anything. But if you heavily integrate with external services, you should consider whether your new hot orchestrator supports what you actually use. So a few takeaways to sum up those things. Do not process data on orchestration workers. This is the most basic and most grave mistake that you can make. Absolutely, you should process data externally. You should host orchestrator or Kubernetes or use some cloud-hosted version because this will pay off. You can also use some managed Kubernetes services if you do not want to fully commit to cloud-based orchestrator. You should use separate Git repos, separate your orchestrator as well. This will need to scale in the future, I promise you. You should separate your tasks dependencies because, okay, not separating your task dependencies will also be a very, very bad mistake. You should anticipate failure, use retries for all your tasks, write your code to be resilient, for your tasks to be idempotent. You should also consider various capabilities when choosing your orchestrator. You should absolutely take like a few days, a week, 2 weeks to read about orchestrators, to consider their strengths, weaknesses, to choose your orchestrator, because changing the orchestrator when you have something set up, especially with Kubernetes, with accesses, with pulling secrets, it's very hard, especially in larger companies. So you should absolutely consider this well when you start. So what would I use? And this is the personal opinion. This is absolutely a warning. This is what I think based on my experiences. So I would typically use Apache Airflow because it's mature. It's maybe not the latest, the hottest, but it's proven. It really works. It's for enterprise, for company-wide orchestration, it's a very general solution, a lot of integrations. If I had to go for something, I would just deploy a Helm chart for Airflow on Kubernetes and go with it. Flight is one of the new hot players and actually looks very nice for MLOps because it's actually very much aimed at machine learning, at Python, with heavy Kubernetes integration. So this looks very, very promising for this more specialized thing. And AWS Step Functions, if you use AWS for especially simpler cases, you can use Metaflow on top of it. So it's maybe not that nice to use in a raw form, but there are many SDKs, many abstractions over Step Functions. And also, if you have less technical data scientists, you should consider Metaflow because it's extremely easy to use, extremely easy to start working with. Okay, so thanks for listening to my presentation. Remember to rate it.
Thank you very much, Jakub. So if you have any questions to Jakub about pipeline orchestration, we have like 5 minutes, so feel free to ask them. I will reach out to you with the microphone.
Thanks, great talk. Maybe if you could quickly comment on another orchestrators from your first slide, what's the pros and cons? That would be great. Thanks.
Okay, so there are a lot of orchestrators there. Sorry. Okay, so there are a lot of orchestrators, but I will try to quickly summarize. Argo is great for DevOps. This is made for Kubernetes for lower level tasks, especially if you don't use Python, but or other like typically DevOps tasks Go. This Argo is very, very good. Flight for machine learning. AWS Step Functions I talked about. Prefect actually had a big makeover in 2.0 version quite recently. I very much, I think this is a great framework and a very nice looking code, but the documentation is absolutely terrible. Documentation is like, at least Google doesn't like Prefect documentation. And also the name is quite generic, so it's hard to search for things for Prefect. So, but I have heard a lot of good opinions about it, very nice looking code. Also, Prefect is more dynamic than other options, so you can make more dynamic DAGs if they change or tasks change. Dagster, similarly, Dagster tries very, very hard to steal from Airflow competition, and it has a lot of very nice tutorials. They are trying very hard to break into this space. So Dagster is also, I think, one of the very good players. In terms of the syntax sugar, Kedro is very good also if you have less technical scientists. ZenML is the least popular of those three, so I would probably choose one of those two. Metaflow is more AWS heavy also. So Metaflow is, because it's used by and developed by Netflix, they use AWS, but it's also very easy to use, but more AWS heavy than Kedro, for example. Okay, so I hope this answers this.
Feel free to ask more questions.
Maybe where you will put here Kubeflow? Hello, question was where you will put here for the orchestrator slide or here the Kubeflow. I think it's more suitable for GCP, as I don't know if AWS has implementation of the Kubeflow.
Kubeflow is an interesting case because I would put it in the graveyard for a simple reason, because it's no longer developed really. Because Google really likes to, bury their projects. And actually, I had a discussion on Reddit, and it seems that in the last few months, Google really has dropped from developing the open source Kubeflow. So Vertex AI absolutely uses Kubeflow underneath, but it's more of their very advanced, more private implementation. So I would absolutely use Vertex AI if I use GCP, but I would probably not use open source Kubeflow, because I think it really lost popularity with the troubles with the open source foundation, with the Google support. So it's more similar to Argo, definitely, but I would use some other Argo-based projects rather than Kubeflow currently.
Yes, I read that the lead developer of the Kubeflow from Google moved to Microsoft at one point, and I think since 1 year the documentation status of the version 1 is in the next month will be version 2, and nothing happened.
Yeah, exactly. So Kubeflow is like an unfortunate development.
But at the end of the day, it's a great tool, very flexible. If you make it work, it's one of the best I've seen.
Yeah, I would absolutely use Vertex AI if I use GCP. It's great. It's managed. Absolutely.
Okay. Thank you very much for your questions. Thank you again for your presentation. Please remember to leave feedback about this presentation either by scanning the QR code at the end that was shown before, or on our website. And the next presentation will take place in about 15 minutes. So please give a last round of applause to Jakub.